Hello and welcome to a presentation on caving in Wayne County, Kentucky. Um, Thank you for spending a little time with us. My name is Lee Floria. I'm out of Bloomington, Indiana, and I work for the Indiana Geological and Water Survey.
Oh, hi. My name is Sarah Burgess, and I'm also centered in Indiana right now. And I'm a graduate student finishing up my master's thesis at IU.
Howdy, folks. This is Brian Devine. I am coming out of Columbus, Ohio.
And I am Chris Bauer out of Cincinnati, Ohio.
Thanks to each of you for helping out a little bit today. So as we go through, let me first tell you where we're at, what we're looking at, and then we'll move on. So we're primarily looking at the Otter Creek watershed, which is in just the southernmost Kentucky, right on the Tennessee state line. You can see that in the inset map, the pink rectangle, and then the larger map shows you sort of the broader perspective of Otter Creek and many of the larger springs and caves. The mapped caves, this is a bit out of date, but the mapped caves are shown as line plots, pink line plots. And we're going to be focusing really on two places. One is Sulfur Mountain, and we're really going to use that as a whet the appetite for the main part of the show, which is looking further to the south at Spelunger Cave, which is near the community of Slickford. And so just overall, just so you know, this is a tributary of the Cumberland River. It is on the edge of the Cumberland Escarpment, and since the late 90s, a group including us and many others have mapped about us, or mapped more than 65 kilometers of pretty impressive cave. So with that said, I'll turn it over to Brian for just a moment.
All right, cool. Thanks, Lee. So this is an establishing shot just to show some of the character of the field house, which has been the field house of a loose amalgam of cavers that refer to ourselves as Friend of Upper Cumberland Karst. I've been coming to this field house since I got into project caving around 2014. For comparison's sake, the only thing I could think to dredge out would be to say if Germany Valley Karst Society is the only other field house I know, this one would sleep fewer people, but might have a little nicer amenities. There is room for about 7 people there, all mod cons as these things go. And beyond that, we can, for transition's sake, look at our current digs that we're reduced to on top of Edwards Mountain because of COVID. This specifically is a camp that is basically dig-centric in terms of what it's been pressed into service to do for us. There's a couple of leads, most of which you'll hear about later, that we're kind of pecking away at from the top down in shifts of 2 so we can socially distance. So this is on top of the Edwards Mountain camp. And then we are sort of moving across the county northeasterly to what would have been the focus of the 2019 exploration presentation from this same group of folks that was really concentric on Sulfur Mountain. Sulfur Mountain was a hot commodity because for a long time we wanted to achieve something we were called the Golden Spike, to sort of allegorically reference the conjoining of the 2 railroad systems from west to east. There was Skert Well, a pit cave that you would have gone in attempting to go easterly to connect eventually with what we surmised would be passage going over to Bowman's pit, which April 20th of last year went to plan. They are now a conjoined system. And then the interest really sorted to swing over to Spelungers, which had been dormant and really sprang back into life at about the same time we made our connection. Remaining leads in Bowman's, which were sort of like dancing along with our cursor there on the image, are largely at a significant remove from the entrance. They are supported by a pretty cushy camp that we've got, 2.25-ish hours back in there. And there's at least 1 or 2 leads that sort of still have, get people juiced when you talk about them, maybe enough to make a run at them, including One is a beckoning hole in a shale layer that might get us through a perforation and up into a cave of a different character or type. And then what had a pulse this time last year and no longer really does is a pit that some of us were trying to climb that really has atrocious rock when you're trying to crest the lip. So we largely are conceding that that is not a front burner project cave, but just as an update, it's still got some things going on. And I think that gives us our segue to hopscotch back southwest to Edwards Mountain. And there goes that.
Yeah, thank you. Yeah, so as Brian mentioned, we're going to switch focus and really spend the rest of this time on Edwards Mountain. And here you go. This is the overview. That's my son sitting on top of a sandstone cliff looking down into the Otter Creek Valley. And this is on Edwards Mountain. The photo's taken from right there. And a couple of things. The one is that there are lots of large caves that surround the periphery of Edwards Mountain, including some that we've talked about in the past. But of key interest is this region shown in the yellow box, which is sort of the southwest side of the core of Edwards Mountain. And in particular, this saddle on this ridge spur going off to the southwest is where Spelungers Cave was located, I found and blasted into many years ago. And that really provided access into what the rest of this talk focuses in on. So the yellow box is going to encompass most of the leads and some of the highlights of surface work that we've been doing. And I'm going to turn that over now to Brian to start that.
I'm Chris. I'm going to take it.
I did that last time. Hi, Chris.
Sure.
How you doing?
Hello. So we're going to talk about the Spelungers project on Edwards Mountain. Just a little bit of background on the project. It was found in the early 2000s and blasted open, like Lee was saying. It was named for Paul Unger, Cecilio Unger. And then it was sort of put on the back burner and borderline abandoned for about 8 or 9 years. The original rigging didn't make a lot of people happy. There were some bolts and some questionable rock. It was a concern. And about 2.5 years ago, a group of us went in with some better bolts and spent a day just entirely re-rigging the entrance, which is significant because for this cave, you pretty much are on rope the nanosecond you are underneath the drip line until you've made a couple descents and a traverse that take you about 200 feet further down. The major drop being the 170-foot drop that you're seeing there, which is also notable because it's just to the side of a large waterfall that's really only super inundating during heavy rain. So this is the shot you're looking at now during heavy rain. And just the other weekend, there was another shot there that I think was on here previously, but there's not always that much water. There we go. So you can see that varies a little bit. The upper levels were not really a focus this year. That was our primary focus in the last year or so. But after we made some breakthroughs on the lower levels, we sort of put the upper levels on the back burner. There is still one really promising and a couple kind of promising leads back there, but that's not been the focus of our exploration this year. The main route takes us down a third drop, which you can see down on the left corner there. The third drop is very tight and is at the base of that large waterfall that we were looking at earlier. That will feature later in the story. There have been a couple trips to survey things around this main route, but it hasn't really been the biggest focus of the last year. The upstream section, which has become the focus of the last few months, is really significant because we made a major breakthrough there that we're going to talk about in the next slide. We've gotten a lot of footage in that area, and it is also notable because it's heading almost due north, which makes it correspond to some superficial leads that we're going to talk about later in the program. So the three upstream trips that have been the most fruitful in the last year, the first was the monsoon room trip, which was not named at the start of the trip because we did not know we were going to find the monsoon room. That would have been a spoiler. That took place in December 21st. It was Amy Skoronsky, Sarah Burgess, Eric Steinberg, and myself. We were continuing a survey through Dry Canyon. And one thing that was notable that we noticed pretty quickly is that there were some animal prints found that were likely cat prints, and some animal remains found, some bones found as well. So that was pretty promising. There have been cat prints found in several parts of this cave, and those parts are not physically proximate. So it's very likely there have been several cases where large mammals, quotation marks, have made their way into the cave there. We surveyed 679 feet. We had several leads off of the main passage there. And most significantly, we discovered a 94-foot dome with a very, very large, very voluminous waterfall in it. That was a nice little feather in the cap for that trip. The next survey was the following weekend. That was a Fisherman's Wife Dream survey. That was named for the really impressive helictite passage that we found, which covered about 200 feet of the 1,000 feet surveyed. Mostly borehole, but like I said, about 200 feet of it was very, very heavily decorated with these helictites. And then our other big discovery upstream was just this last weekend. This was our new domes trip, which was Sarah Lima, Mandy Bergwell, Mitch Cottle, and myself. We continued to survey that same passage through some breakdown, and as well as several leads at nicely formatted passages. We also found two large domes, one of which we could not safely measure the height of at that time. The other one is 124 feet. So that's pretty significant, and this is all in that northward trending passage. The downstream section had been our focus until we found the monster room. Lots of leads down in that area. The big trip we're going to talk about, you can see there've been a number of trips down there with varying degrees of footage found. The trip we're going to really discuss is our Thanksgiving weekend camp trip. Before we go to the next slide, the picture to the left there, that is actually the deepest point in the cave at this point. So there is a lead going with some more depth potential.
20 feet.
Some more depth potential in that direction. The camp trip was on Thanksgiving weekend. Consisted of Adam Mathis, Mitch Cottle, Mandy Birdwell, Sarah Burgess, and myself. We were surveying and exploring a dry passage downstream, and we established the Starry Night Camp, which was named because the ceiling in that camp is gypsum coated in manganese with then new gypsum formations on top of that, which creates a really cool effect of looks like a dark sky with the sort of sparkly crystals there. We surveyed 1,150 feet. There were multiple leads. One of the more significant things was there was a point at which there were several high end feeders, and we felt a noticeable temperature difference in that area. We also found bat bones nearby. We were not able to locate the source of that colder air, but it was noticeably different from the rest of the cave in just that spot. And obviously, as the end of November, it was colder outside. Just a few other, there's a picture of the cat prints there. Some really nice gypsum needles that are right off of the main route. And then we're going to watch a few seconds of this video, which is going to show you one of the concerns with the third drop, especially in a heavy rainfall event, and especially if you're not aware that it's coming. So this is that same drop that you saw Sarah going down in one of the earlier slides, and there were a few drips there. This was when there was an unforeseen large rainfall event that hit while we were in the cave. While it did not prevent an egress in any way, shape, or form, it made it really interesting, and not in the most fun way.
Footage looks great, though, I tell you what.
Footage does look great,
Worth it.
for sure. Would do again. Maybe not.
Safely.
Would check the weather first. So as of June 2020, we have 2.8 miles of surveyed passage with a lot of potential for more passage. Lots of walking and borehole leads that still need to be explored. And we are at 322 feet of depth, which is pretty significant when you consider some of the things that are going to be talked about by Sarah.
It's actually Lee first, though.
Oh, sorry. Lee's talking first.
Get excited.
That's correct. I had to unmute myself. Thanks, Chris. So yeah, we'll make a transition here to some other things that are happening on the surface and that may actually lead into Spelungers, as Chris was hinting at. And so first, let me kind of backtrack and give you like a 30-second perspective of why this region is caving important in a lot of ways. Number one is, as I mentioned, you have a fairly large package of limestone on the flank of Edwards Mountain. But not only that, you also are on an anticline, and that anticline has long been known. And on the crest of that anticline, on Otter Creek and in the tributaries, such as on the image to the left, are sets of sulfur seeps coming into the base level streams. And these are really high in hydrogen sulfide when you come up on them, and you can see the filamentous sulfur metabolizing bacterias growing on these reaches of streams. And then economically, first of all, in the late 1890s and early 1900s, there were about 4,000 wells drilled in the region in shallow petroleum reservoirs. And here on the crest of the anticline, as you can see, this is a recently drilled well. You can't see the pump jack, but here's the holding tank. And this is, I mean, you could almost see Spelungers, like Edwards Mountain in the background, and Spelungers is just right off to the right of that image. So there obviously is some ongoing interest in oil. And that had then led us to help understand more about the geology by remapping the superficial outcropping, the dips and strikes, and try to learn more about a more granular level detail on the anticline, flexures thereof, where the crest was, and any faults that were occurring on that. And so here's another perspective of Sarah coming out of a pit just right on the edge of one of the fault scarps that we found. The upper unit that you see is the Pennington, the first sandstone in the Pennington Formation, and then she's coming out of the Bangor limestone right on the side of a road. So inside the cave, there's also some really interesting stuff going on. And in the past, I've waxed ecstatic on hypogene influences and the roles of chert and stuff on how and why the cave had such interesting morphology. But on closer look and mapping and getting back in there almost a decade later, there's other stuff happening. Like, for example, in both of these images, you can see this strange sort of passage morphology, and in there are these interesting outcrops on the walls. And if you look at them more closely, you see that they're outlining a Paleokarst feature, and this Paleokarst feature is prevalent throughout the main part of the cave. And the size and shape of these are really intriguing. And what I think we're looking at are caves that form syngenetic with the rock. So we're looking at Mississippian age caves and that were formed in a place kind of like what the modern day Bahamas are today, but then were filled in and preserved for almost 300 million years and are now re-excavated into the modern cave. So then within the cave, we've also been making the map itself of the cave helps us understand the geologic structure, but then the smaller features therein are really helping us to assess what's going on. So inside the Litterbox Canyon on that north trending passage, you can see a fault plane that Sarah's highlighting. The north is approximately north, a little bit east of north, and you can see slickensides on that fault plane. And those slickensides are not oriented up and down as one might expect from a normal fault or a reverse fault. And on the geologic map, it is shown as such. So these are shown as north-south oriented along the axis of the anticline, which means that we're looking at a strike-slip sort of situation. And in the orientation of this means it's more like of a right lateral fault, which gives a whole new perspective on like what the origin of the anticline might be. So in the upper right image, you can see that really intense fracturing of the limestone in one of those Paleokarst features and some infilling of calcite veining, which gives, in some places in the cave, actual boxwork that I haven't seen in a lot of places in the eastern United States. And in the lower right image, you can see mineralization that Sarah is highlighting. And though you can't see the color here, we spent quite a bit of time with lights and staring to assure ourselves that it indeed was purple. And so we have a sample.
It was purple fluorite.
Yeah, and the most likely scenario is that there is fluorite in there. But there's also chert embedded in it. So these are chert stringers, and inside those chert stringers are fluorite crystals, or at least what we surmise as fluorite crystals. So I'll turn this back over to Sarah now to close us out with a couple of other ideas and notes.
Well, I was just going to say, so in addition to the structural influences that the anticline and the faults associated with it have on the cave, it also serves as a trap for petroleum. And we saw that on the surface with the reservoir for oil. But it also shows up inside the cave. So this is the stream passage of Spelungers, and there are actually some very large sulfur seeps down in the stream. This is not the largest one highlighted in the picture, but the white is that filamentous sulfur metabolizing bacteria, and the black is a crude petroleum product. The image on the right is a sample of that petroleum product being taken, and the chromatography that a colleague ran for us of that product shows that it still has a few biomarkers that could be used in the future to trace it to its reservoir. And that has interesting implications for fluid migration and, again, cave formation. So in addition to helping out with the science, I've been helping out manage the data for the cave. So this is the line plot of Spelungers, shown in red. And then in addition to it, we have our 3 surface leads that we're hoping are going to connect in. 2 of them are a lot closer, and we discovered basically concurrently with some of the discoveries Chris talked about earlier. And then the cave in the far north is an older discovery that we're revisiting now because of hope that it will connect in. You can see in the text there the elevations of those cave entrances are noted. And what's happening is the anticlinal structure and the dip of the beds is adding vertical potential to the limestone package on Edwards Mountain. This is really exciting because Spelungers is already sizably deep at 322 feet, but we have about 20 feet to go from downstream, where I showed earlier, to the base level at Otter Creek. And anywhere from 50 to potentially 150 feet of additional height added if we can get some of these surface leads connected. Next slide. So here's the profile to kind of contextualize that a little bit more. You can see Spelungers entrance, the monsoon room, and then Green Garter Pit, Elimination Hole, and Gammeldansk. Green Garter Pit was found right around the same time as the monsoon room, Elimination Hole slightly after that, and Gammeldansk was discovered back in 2008. Here's a closer look at some of these leads. So Green Garter Pit was discovered almost concurrently with the monsoon room, and that happened in the wet season of Kentucky. So you can see the seasonal stream is dumping water straight into the ground. And we can't really believe that we missed it before, but we're really happy we found it now. The problem is the water makes it really hard to work on. Next slide. We actually had to put a tarp over the pit to be able to work on it at all without going hypothermic. The problem is the lead is still small and wet. So, yes, jokes. It's really just difficult, but I think there's a video if we go to the next one. This shows just how small and difficult to work in the lead is, but it has such good potential for connecting in. We have a very probable hydrologic connection being observed between the surface and pretty deep in the cave. Next. This is Elimination Hole. The video clip playing is of the original entrance to Elimination Hole. We've modified it since. You can see it's very tight and not easy to get in and out of. Now we have a clean drop and a relay in to keep the rope from dragging along the edge. When you rappel down into the cave, you descend 75 feet and encounter 2 waterfalls with the water sinking beyond the wall. There is a small keyhole passage at the bottom of this cave that has airflow. We've been digging on it and can now hear the sound of water beyond it. And it's actually quite interesting because it starts off as a drip and then escalates to a trickle and then a roar. After hearing it, we suggested that we're hearing a siphon effect where water is pooling up in a reservoir and then falling over some extent of drop and then refilling. So whatever it is, it's gonna be exciting and we're looking to get around to witnessing it firsthand. And then this is Gammeldansk, which again was discovered about 12 years ago, and it consists of multiple drops, but you can do it with one rope with some care. You descend about 90 feet into the cave and then come upon an 8-foot fault scar. On one side, you're standing on the Hartzell Formation, and looking across, there is no Hartzell Formation. If you use some webbing as a hand line, you can get down the sheer vertical face, and you encounter a small and terrible lead, which folk and legend tells is filled with crickets. And back in the early days of exploration of this cave, that deterred further mapping. But I have been in the crawl, and I can attest the crickets are probably seasonal. So now's the time to get in there and explore and see if we can connect it into the rest of the cave. The crawl is trending southward, looking to meet up with northward leads. And I'll turn it back to someone to say goodbye.
Thanks, Sarah.
Goodbye.
Yeah, hi. So this mute, unmute thing, sometimes I forget. So I've been screaming in the background and nobody heard me. No, everything's fine. I appreciate all 3 of you jumping in and helping out with this, and I hope that anybody who's watching this has come away with a little sense of what we've been up to for the past year, before and after COVID, and there is certainly a lot left to do, and there's already some plans moving forward over the next few months. With luck, you'll hear from us again next year. And we'll have perhaps some exciting news to tell you about connections and depth potential, and you know, seeing if we can break that 450-foot barrier that's always been elusive in Kentucky. to get past. So thank you very much. I hope that you've enjoyed, and I will end that now. Thank you very much. Have a good day.